In the previous lecture, we introduced the importance of CHP or combined heat and power. So here we are going to compare CHP and the traditional part. So from the red line I have divided the two sides. In the CHP side, we are using a diesel engine to provide energy in order to get both electrical power as well as thermal power. In order to do that, we are giving 100 units. 100 kilowatts, maybe watts, kilowatt hours, whatever. We are using 100 units. In the traditional side, in order to get the required electrical power, we need to have a separate power station and separate energy, input energy has to be given to this part. In order to get the thermal power, we need to have a boiler and input energy has to be given to that boiler separately. So let's consider here. Normally we can say the efficiency of this diesel engine when generating electric power is about 40%. So if the efficiency here is about 40%, if the efficiency here is about 40%, then we are going to have 40 units of electrical power. We are going to have 40 units here. That means 60% of the heat generated by the combustion of diesel is going to be wasted. We are using a thermal or heat recovery system to utilize as much as possible energy from that waste. Let's say we can save about 67% of the waste heat. That is, the total will be 67% into 60, that means about 40.2 units. So using the CHP, we are giving an input energy of 100 to the diesel engine. From this one, 40% efficiency is there, so that we are going to get 40 electrical power units, and 60% of the energy from this diesel engine is going to be wasted, and we are using an energy recovery system with an efficiency of 67%. As a result, we are able to recover 40.2 units of thermal power. So which means by utilizing 100 units, we have actually used 80.2 units. So the overall efficiency of the CHP system is 80.2. On the other hand, if we consider this traditional one, we can say normally in the power plant the efficiency is about 38%. Therefore, we need to have an input energy about 105.3 units. In the boiler, the efficiency is quite high compared to the power plant. Here the efficiency is about 82. As a result, we need to have an input energy about 49 units, sorry. Therefore, we have actually used 154, right? 154.3 units. Here we have used 100 units, and here we have used 153 units. So we had to have used 54.3 additional energy in order to get the same output in the electrical power and the thermal power. So here the efficiency can be considered as 8.2 divided by 154.3, which means about 52%, right? 52% efficiency here. Here the efficiency is 8.2. So one might ask, wow, this is wonderful, right? Because one might say we have the overall efficiency is 8.2. If we use a traditional system, it is about only 52. That means we have almost 30% enhancement in the efficiency. And why don't we use these kind of things everywhere? Well, at this situation, finally we have to consider the payback periods, whether this is economical, and at the same time, when we are using this kind of system, we have to make sure that when we are using this CHP, we have to make sure that the electrical or the power requirement and the thermal energy requirement throughout this year, throughout this operation, is going to be sort of a constant value. If not, if we are using this, if we don't need thermal power at certain period of the year, then this might not be really going to save your money. Therefore, we have to actually forecast our energy requirements and see whether this is really going to work. And at the same time, we have to consider about another important factor, that is heat to power ratio. Heat to power ratio. Now here heat is 40.2% units and power is 40 units, so heat to power ratio is almost 1. So we generally say if we have a heat to power ratio of 1, then that would be the optimum situation for use of CHP. If the heat to power ratio is going to be increased, then the amount of saving that we are going to get is going to be reduced. Now here you are going to save 30%. Here it is 80, here it is 52, so almost 30% is saved here. But if we are going to increase this value, then the amount of saving is going to be less. So let's consider about that one.